The next thing that I want to talk about are integers and unsigned integers. What are integers? What are unsigned integers? Integers and unsigned integers are full numbers, meaning they have no decimal places, and the difference between unsigned and signed integers is the signed ones can go to negative, while the unsigned integers only range from 0 to something really large. How large can they go? They can go between 2 to the power of 8 to 2 to the power of 256 minus 1. So from 256, from 0 to 256, and from 0 to 2 to the power of 256 minus 1. And let's define some. Let's just play around with it because they have some very particular side effects in specific Solidity versions. So let's just start with a new smart contract over here. Example, let's call this example uint.sol. Bring over the SPDX license identifier and the pragma line. Let's just define an integer, call it uint myint. Let's call it my uint because that's better. Again, we are going to make this public because we have then a getter function. So if you are just running this, if you are just deploying this over here, and then we are clicking on my uint by default, it's going to be 0. There's nothing initialized. We can obviously, or maybe not obviously, but we can also define a specific value at the beginning. So if you want to have a storage variable already initialized with a specific value, then you can do this as well. It's going to be the initial value, or you can do it in a constructor, which we are going to do later. There's one thing, if it's just an advanced use case, but if you are assigning a standard value that is already the default value for the uninitialized variable, then it will actually cost extra gas. I know we're not quite there yet with the gas, but maybe something to keep in mind. If you just need the default value, just leave it blank as a habit. So let's write a setter function, set my uint, my uint, public, and then my uint is my uint, so we can actually look at that. Got the wrong one, so we can update this over here. Now, uint alone is actually an alias for uint 256, and this is the size of the unsigned integer variable that you have then. So this one could store values from 0 to 2 to the power of 256 minus 1, which is pretty large. And it's very beneficial that it's pretty large. It's much larger than the max int from JavaScript. That's why you maybe have seen already that some of the Web3 projects are using a library called big int or big number. So you can actually work with much larger numbers than JavaScript in the integer space gives you. You can also have smaller unsigned integers and signed integers. They are ranging from uint 8, my uint 8, to uint 16, uint 32, uint 64, and so on. So you can have different sizes, and I mean, for a beginner, obviously, it would make sense to leave everything as uint 256, so you have the full space. But if you want to save on storage cost, on gas cost, then you need to define smaller ones. But beware, there might be certain side effects down the road if you suddenly have used up the space, the integer space that you can actually use there. So let's try what happens if we are going to simply increment my uint 8 until it hits the max uint 8 value, which is 256. So let's go function increment uint 8, And then we are going to myUint8, and instead of writing is myUint8 plus 1, we are just going to write plus plus, which is the same as just incrementing it by 1. Now let's deploy this, and instead of starting here with 0, we start with 250. So we can, after 5 times clicking on increment uint8, then see what happens if we hit the max value. So my uint8 is now 250. I increment it, 251, increment it again, 3, 4, 5. Oh, what happened here? Oh no, it can store 256 values, so the max is actually 255, so it goes from 0 to 255, or 2 to the power of 8 minus 1. So it hit an error here. It says, well, there's like not enough information, blah, 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 and it is a VM error revert, and it reverted to its initial state, meaning the transaction that we sent failed, and it stays at 256. And there's a huge difference to previous versions of Solidity, which were just rolling over back to 0, which is something I want to discuss specifically in the next lecture. For now, let's define an signed integer as a last variable. So we have covered that as well. Let's just define an int, public myInt, and just go to -10. And then we are going to increment that integer over to over 0. myInt plus plus, and over here you can go from -2 to the power of 128 minus 2 to the power of 128 to plus 2 to the power of 128 minus 1, I think was it. So the address, I mean the number space is just shifted. Instead of 0 to 2 to the power of 256 minus 1, it's going from minus until it hits 0 and then the plus side. And yeah, if you're just running that, then the integer is -10. If you are incrementing that integer 10 times, or yeah, then it goes to plus. On the other hand, if we are trying to decrement an unsigned integer, then you probably guessed it already right. myUint minus minus, so that would decrement it by 1. myUint is 0. If we decrement it, it will fail because it cannot go to negative numbers. Yeah, that's it. Basically what I wanted to cover with integers and unsigned integers. Obviously, there is also comparisons, like is it larger, is it smaller, is it equal? You can also shift, which we are not going to use. And there is arithmetic operations like plus, minus, multiplication, modulo, and exponentiation. So exponentiation is maybe a little bit special because it is the double star. So if you want to have 2 to the power of 4, then you would write it like this. And if you deploy this, then you have 16, which is 2 to the power of 4. All right, that's it for this one. I will see you in the next one where we are discussing a special case, the integer rollovers.